Hi students, and welcome to your lesson on the coordinate plane. What we're going to be looking at in this lesson is how you plot or mark points and label points on the coordinate plane. As you're reading through this, one of the questions you might be asking yourself is, do I know what coordinate plane is? Do I remember seeing this before? We're going to start off with some of that vocabulary like coordinate plane that you're going to hear a lot in this lesson. So what I'm starting off with is this image here. There's a lot of vocabulary that goes with this image. The first part, this entire thing, or this graph, we call our coordinate plane. Now sometimes I'll get lazy and I'll call it a graph. A coordinate plane is a type of graph, but what makes this specifically a coordinate plane are these two things right here, these number lines. I've got this one here that goes left and right. We call this number line our x-axis. And then you've got another number line that goes up and down right here. We call this vertical number line our y-axis. Right here in the middle, where those two number lines intersect, there's no number written. Do you know what number would be there? Well, between -1 and 1 is 0. So that point right there at 0 on both number lines, we call that point the origin. Origin is like a fancy word for the beginning. This coordinate plane, this graph, begins here at 0. And these arrows means it goes forever in all four of those directions. So the numbers only go 1, 2, 3, 4, and then there's a fifth line here. But this arrow means it keeps going. It doesn't stop at 5. So depending on what you're talking about with your coordinate plane, sometimes you might want to use a smaller graph like this, or maybe you want to use a larger graph or coordinate plane that goes up to a higher number. So far we've got the entire graph we call the coordinate plane. The coordinate plane is this graph that has two number lines. We've got this horizontal one we call the x-axis. We've got this vertical one we call the y-axis. The last word we've got is the name of these four areas. So notice here in purple we've got 4 different parts of our graph labeled with Roman numerals. Each of these 4 parts we call a quadrant. Quadrant because quad means 4, and there are 4 areas of our coordinate plane. We use quadrants to help describe where something is. So if I've got this smiley face over here, I could say that smiley face is in quadrant 1. It just helps you be more specific when you're saying where something is. Now, I drew a smiley face, but usually what you see on our coordinate plane in this class is points. At each of these locations where those graph lines intersect, you can label with a point. And each of those points are represented with 2 numbers, a number from our x-axis and a number from our y-axis. So when we said today we're going to talk about plotting and labeling points, we're talking specifically how you can name each of these points using these numbers from our number line. And where you, if I give you the numbers, where you would put that point. To practice first with this vocabulary, because like I said, you're going to hear a lot of these vocabulary words today. I've got these 5 questions for you. So go ahead, using those words we just looked at, try filling in what word would go in each of these blanks. So the first one, the name of the horizontal number line is our x-axis. The name of the vertical number line is our y-axis. Vertical, just as a reminder, goes up and down, and horizontal goes sideways. The next one, this one is the name of the graph formed by the x and y-axis. The name of that graph we just saw is coordinate plane. The next one says the coordinate plane is split into 4 regions, each called a quadrant. Remember 4 and quad? That's how you can help remember that one. And then our last one, this is the name of the center of the coordinate plane. What did we call that point in the middle? We called it the origin, because it's where our coordinate plane begins. Again, these are words you're going to hear a lot in this lesson. I recommend that you write down the definitions if you have not already. But let's go ahead and start getting into the math. Now we had mentioned earlier, each of those points on our coordinate plane is going to be represented with 2 numbers. A point on your coordinate plane could look something like this. We could represent it with these 2 numbers. We call the first number your x-coordinate, because that first number is going to tell you where it is on that x-axis, that horizontal number line. You can probably guess the second number then we're going to call the y-coordinate, and that y-coordinate is going to tell you where that point is on your vertical number line. So basically this number tells you where it is sideways, and this number tells you where it is vertically. Together we call this pair of numbers a coordinate. So the coordinate is what you call the numbers together, and the coordinate represents a point somewhere on your coordinate plane, which is why that entire graph is called coordinate plane. So using what we said here, this is how we're going to plot our points on the number line, and it's going to help us label our points later on. So the first part of this lesson is going to be on how you can plot different points using your coordinate plane. Now the first point we're going to plot is called point A, and I want to plot my point at the coordinate 1, 4. The way a lot of people do this is they start off by finding where that point is on your x-axis. That first number is always going to be x, and your second number is always going to be your y coordinate. So finding this point, I'm going to start off by going to my x-axis, which is this horizontal one, and finding the number 1. I'm going to go and find 1. I want to make sure it's positive 1. Then our next step is we want to find 4 on our y-axis. So my point is going to be here on 1, and then 4 on y. So my point is where those 2 numbers intersect, right there. Again, this point is the point that has 1 on our x-axis and 4 on our y-axis. So if I find 1 and 4, find where those meet, it's this point right here. You can also just start at 1 on your x-axis and then count up 4. So I could start here and I could count 1, 2, 3, 4, and put my point there. Now there's a lot of points we're going to end up doing, so to help me keep track of which point is which, that's why we've got these letters here. I'm calling that first point A, so I'm going to go ahead and label this point with an A so that I know later on that's where the point ended up being. We're going to do a couple more of these. Point B, I want to go to -2, -4. Again, I'm going to start by going to -2 on my x-axis and then going to -4 on my y-axis. So I'm going to find on x, -2, that's right here. And I'm going to find -4 on y, that's right here. What you want to be doing either with your fingers, your eyes, is finding where those 2 numbers intersect, because that's where our part will be. So I'm trying to find where those 2 numbers intersect. That's this point right here. I wouldn't want any of those lines drawn on my paper, just that final point, but that's what I'm doing, finding those 2 numbers and then finding that point. Again, a different way I've seen students do it is they just start at -2 on your x-axis. So x-axis, -2, and then count down 4. I could count down 1, 2, 3, 4, and find my point that way. Last part, since it's point B, I'm gonna write a little B next to it. For number C, go ahead and see if you can describe how you would find point C. How would you find the point at the coordinate 5, 2? All right, let's see how you did. I want to go to 5 on my x-axis and 2 on my y-axis. So I could find 5 on my x-axis. And then since it's a positive 2, I want to go up 1, 2. This would be my final point. Did you remember to say, put a C by it? It's okay if you didn't. Just remember we want to label each of these points with the letter. Now looking at number 4, point D, it looks pretty similar, right? I've got a 2 and a 5, a 2 and a 5. It's the same numbers. Do you think this point and this point are the same? Yes or no? Why or why not? Go ahead and answer that now. Well, the best way to see if they're the same is, let's go ahead and plot this point. We've got 2 on my x-axis, 5 on my y-axis. If I go to find that point, I need to go to 2 on my x-axis, which is right here, and then 5 on my y-axis, which is up here at the top. I could also count 1, 2, 3, 4, 5, but our final point ends up being here. If you said no, they're not going to be the same, awesome job. You're right, they ended up in different spots. What that means with coordinates is that the order of these numbers is really important. Sometimes in other math classes, teachers describe this instead of as a coordinate as an ordered pair, really to emphasize the fact that the order of those numbers is crucial. You switch around those numbers, it's going to give you a different point. Another thing I want to mention here is there's only one point at this location. There's only one pair of numbers that matches up with this point, and that one pair of numbers is 2, 5. Any other pair of numbers is going to give you a different point on the graph. Each one of these is unique. Each one is individual. With that said, there are 2 last ones we're going to do, and these have zeros in it. Sometimes the zeros can throw students off, so we want to really focus on what a 0 means. So for point E, our x-coordinate is 0, and our y-coordinate is 2. If your x-coordinate is 0, it means on our x-axis, on our horizontal number line, it was here. The point was at 0. That means that we don't need to move sideways. A 0 as an x-coordinate means you're staying right here in the middle of your graph. You don't have to move sideways at all. We do need to move though, because our y-coordinate is 2. So I may not be moving sideways, but I need to move up 1, 2. So our final point would be right here for E. Now there's one last one, the point 0, 0. Where do you think the point 0, 0 is going to be? Well, that first coordinate being 0, our x-coordinate being 0, means we're not moving sideways at all. We're staying right here. And that second coordinate being 0 means we're not moving up or down at all. We're still staying right here. The point 0, 0 is in the center of our coordinate plane. There's a word you learned for that. Our point 0, 0 is the origin. So this point F right here is at the origin of our graph. Now there's a second part to this question. The second part says write the quadrant the point is in. Do you remember what a quadrant is? Quadrants were those 4 areas of our graph. So when I'm asking for the quadrant, I need to know, looking at this graph, which quadrant is quadrant 1, which is quadrant 2, quadrant 3, quadrant 4. If you already had drawn the picture from earlier, you would remember that this one right here is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And remember, we use Roman numerals to label them. You're starting here and you're kind of making the letter C with them. As in like 1, 2, 3, 4. I know Denise likes to say it's a C for coordinate plane. You're going around this direction. Once you know which ones are 1, 2, 3, and 4, it makes this part pretty easy. We could go ahead and say, well, point A is here. A is in quadrant 1. Go ahead and try numbers 2 through 4 for me. All right, B is down here in quadrant 3. C is up here in quadrant 1. D is also up here in quadrant 1. So we've got 1 through 4. For 5, go ahead and take a guess. What quadrant would you say point E is in? All right. My guess is more people than not said E is in quadrant 2. And I say that because notice when I find the point, I wrote the letter E on this side. Now it does not matter where I put that letter E. Notice for this one I put right above it, this point here I put it to the side. If I had written the letter E here, then I bet you more of you would have said quadrant 1. The point of quadrants is to tell you where the point is. So when I'm trying to decide where point E is, I'm not looking at where I put the letter. We want to look at where the point is. The point is right here. The point is in the middle. Now if the point's in the middle, I can't say it's in quadrant 1 or quadrant 2 because it's in between them. This one here, there is no quadrant it's in. Instead, there's a different way we could describe this point. Instead of saying point E is in a quadrant, we could describe it as being somewhere else. Do you know where I would say? Well, we said earlier it's in the middle of the graph. To be more specific and to use a vocabulary word, I could say this point is on our y-axis. So I'm going to say over here, point E is on the y-axis. If I asked you to describe where the point is, it would make more sense to say this because you can't describe it as being in a quadrant. Now keeping that in mind, what do you think we're going to say for point F? Well, we said it earlier, right? F, that point 0, 0, is our origin. So again, because it's in the middle, there's nothing we could say, right? We can't say it's in 1, 2, 3, or 4. I could say that it's on our x-axis and our y-axis, but the most specific way to be is just to say it's our origin. Hopefully these examples were helpful. I'm going to erase all of this, and then there's 3 I'm going to have you try. Okay. So for point A, go ahead and tell me, if you were to graph point A, where would it be? All right, point A is at 4 on our x-axis and then -5 on our y. So A would be right here. For C, go ahead and describe for me how you would graph point C. Well, if you didn't have a graph, I would describe point C by saying you want to move to the right 1, or something about find 1 on your x-axis. And then because it's negative, I would say we want to go down 3 and plot our point there and mark it with a C. You could also say something like find 1 on your x-axis, find -3 on your y-axis, and find the point where those numbers intersect, the point where those 2 numbers meet. Something like that would also work. And then the last one, D. If I were to graph point D, which quadrant would it be in? Well, D is at -4, -2, which is right here. That would be quadrant 1, 2, 3. So this was the first part, which was all about plotting these points. The second part of this is doing the opposite. So now instead of plotting points, I'm over here looking at a graph that already has points marked on it. And instead, what we're going to do is we're going to name the coordinate. We're going to write the numbers that match with the point. Now there's something else different about this graph. If I look at this graph, it's different from those ones before, because there are no numbers on this coordinate plane. Notice our x and our y-axis have nothing, it's just blank. Please, please, please do not go in and start labeling them all yourself. I could give you a really big blank coordinate plane, and I don't want you numbering like 1 through 20 in every direction. Instead, what this is gonna mean is when I'm going to find what numbers each of these points are at, I'm gonna just have to count. So I'll show you, for example, point A, I know from before that there's gonna be parentheses around our coordinate, and there's 2 numbers I'm trying to find. I also know from before that our first number is our x coordinate, and our second number is our y coordinate. So if I wanted to write this coordinate, I could start by counting where A is on our x-axis. So starting here, I want to figure out how far left or right I need to go to get to A. Well, I can see A is on this side, so I'm just going to start counting on our x-axis until I get to where A is at. Now when you go to count, the biggest mistake I see students make is they're counting the boxes. You don't want to count the boxes, you want to count the graph lines, because remember, this point here is on a graph line. So when I go to count, remember the middle is 0, we're just going to count 1, 2, 3, 4. And because I'm counting in this direction, it would be a positive 4. So I can go ahead and say my x coordinate is the number 4. We can now do the same thing to get our y coordinate. You can count over here if you want, or you can just count going straight up to the point. For the same idea, I'm going to count the lines and see how far up I need to go to get to point A. So I could count, remember this is 0, so 1, 2, 3, and I can see point A has a y coordinate of 3. I'm counting up. For counting up, that's in the positive direction, so it would be positive 3. Now eventually you're going to want to be able to do this without making any marks on your graph. If I had given you a lot of points on this coordinate plane, you don't want to have lines marked everywhere as you're trying to count. So just try to count with like your finger or in your head. We'll go ahead and do B together, and then I'll have you try C and D. So for B is right here. So again, I want to start with my x-axis first. I'm going to start by counting on my x-axis over to B. So it would be 1, 2, 3, 4. All right. Notice A and B have the same x-coordinate, and notice on our graph A and B are in the same place horizontally. They're just different vertically, so that's why they have the same x-coordinate, but their y-coordinates would be different. Now for B this time, I'm going to do the same thing. I'm going to count down to B. So this is 0, so I'm going to go 1, 2, 3. Now some people might be tempted to put 3, but notice that's the same as A. If it was the same as A, B would have been up here. Because we're going down, that means that y-coordinate is going to be negative. We want our 3 to be a negative 3. Negative 3 means we would be counting down. All right. Using our coordinate plane here, go ahead and I'm going to have you try C, D, and E. Go ahead and try those for me. All right. C is right here. So for our x coordinate, I would be counting over 1, 2, 3. So we get a positive 3. And then our y coordinate, I'm counting down, so it's negative. I would be going 1, 2, 3, 4, 5. Down 5 means negative 5. For D, D is over here. So first I'm going to count on my x-axis. I'm going to count 1, 2, 3, 4, and that's how I get to D. Now because I'm counting backwards, backwards is negative, so that would be a negative 4. And then for our second part, I'm going down 1, 2, 3. Down 3 means negative 3. For E, E is right here, counting backwards, so negative. 1, 2, 3, 4, 5. And then I'm counting up. Up is positive. Up 1, 2, 3. All right, so we've got those first 5. This last one here is F. Go ahead and try F just to see where you're at. All right, let's see how you did. The reason I wanted to say this one for last is because this point is on an axis, specifically our x-axis here, that can make it a little trickier for students. If I wanted to label our point F, first I want to see where it is on our x-axis. This point is back 1, 2. So that x-axis is -2. For our y-axis though, where is this point? Well, the point it hasn't moved vertically, it's not higher or lower. We didn't move it all. So that means that y-coordinate would be 0. Sometimes those zeros can be tricky for students. Hopefully you did well on this. There is one last part, and that is what it looks like when you're using coordinate planes and plotting points to describe a real life situation. So we've got our coordinate plane right here, and it tells us the graph below, or I guess to the side, shows the number of push-ups and sit-ups each student in the summer PE class was able to complete at the end of the summer. So we've got our coordinate plane here. It says fitness test results. We've got some points. We've got our axes, and then they're labeled. Now, one of the questions I ask in class is, how does this coordinate plane, this graph, look different from all the other ones we've looked at so far in class? Go ahead and try to answer that question. Feel free to mention more than one thing if you notice a couple things that are different about it. Okay, I can't wait to see what you guys said. The parts that we usually talk through, the first is that students really notice immediately there are no graph lines on this. That's not always the case, but it does mean that when you're going to find points, you want to be really careful. You don't want to make sure you're tracing straight lines. Another thing I hear students mention is the numbers. Notice here that the numbers aren't going up by 1 like they did with the other graphs. Instead, like 35, 40, 45, 50, it's counting up by 5s. Sometimes that's helpful to do if you've got a larger range of information, right? If we were using that graph from before, going from 30 to 60, if you're only counting up by 1, that's going to give you a very large graph. The same, notice that sometimes students notice this little zigzag line here. Do you know what that zigzag line means? That zigzag line means you're skipping some numbers. So just like always, right here in the middle is our 0, but they didn't want to have to write, when they created this graph, 5, 10, 15, 20, then 25, because notice none of these points are below that. So to kind of save space on our graph, and to keep it from being like all these little points up here and then nothing in this area, you can use this zigzag line to say, hey, I'm cutting out these numbers. I'll start at 25 and then just count up 5 from there. The last thing that's different about this is that when we look at our coordinate plane, we've got our y-axis here and our x-axis here, but we're missing part of the graph. Right? In our coordinate planes before, it looks like this with 4 quadrants. However, here, I only see 1 quadrant. It's missing this part and this part of our coordinate plane. Go ahead and answer the question, why do you think that is? Why do you think we don't have our x-axis and our y-axis continue in those directions? Well, if it had continued in that direction, what would it have said? 0 is right here where those lines intersect. So back here would have been like -5, -10. Same thing down here. We've gotten like -5, -10, -15. Why don't we want that? Well, it depends on what we're talking about. Here I'm talking about number of push-ups. You can't have negative push-ups. And here it says number of sit-ups. You can't have negative sit-ups. That is why they took out the negative. Now, what do you think? Do you think always the negative quadrants are going to be missing? Well, no. It's going to depend on what you're talking about. Here, if I'm talking about push-ups and sit-ups, you can't have negative push-ups and sit-ups. But if this graph was about like temperature or money or some of those situations we said that you can see negative numbers with, sure. If this was a graph of my bank account, right, like maybe I would need the negative side down here to show that like at one point my bank account was negative. So it's all gonna depend on the situation the graph is talking about. Now that we've gone through the main differences with this coordinate plane compared to our other ones, we can start looking at some of the questions. The first question is asking, why does the graph only have quadrant 1 and not the other quadrants? We've already talked through that question. Go ahead and answer it now. Okay. The second part is asking which student is at the point 30, 55, and what does the coordinate 30, 55 mean on this graph? Well, each of these little points here represents a student. We're just trying to figure out which point is, or which student is here. I could go ahead and, using the information we talked about earlier, find that point by saying, well, the first coordinate is 30, and that's our x coordinate. So I could go to 30, and then our y coordinate is 55. Who is right there? Well, it is student D. Now there's a second part to this question. One of the things I'm just going to use this as an opportunity for is sometimes on those Google Forms you've completed, I've got two questions or two parts to the question. Make sure you're always answering both. So sometimes in class students say student D, done. There's a second part though that says what does 30, 55 mean on this graph? What do those two numbers represent in terms of this situation? Well, it's going to go back to our x and our y axis. That 30 was our x coordinate. So when I find student D is at 30 here, it means they did 30 push-ups. So I could say 30, 55 means the student did 30 push-ups. There's a second part to the sentence, and the 55 would mean that they did 55 sit-ups. And 55 sit-ups. So it could just be something simple like that. I'm asking you to tell me what something means though, it's checking to make sure you could do more than just find the point. You actually understand what the graph is saying. There is one last question. I think one last question. The last part asks us which student was able to do 40 push-ups and 50 sit-ups. And there are 4 options here. Go ahead and try this one. All right. Well, 40 push-ups would be our x coordinate. Push-ups 40, 50 sit-ups, 50 sit-ups. What student is there? Student E. So we would want to see option B, which is student E. Nope, there was one last one. The last question for this is which student was able to do the same amount of sit-ups and push-ups? Sometimes in class this one could take a little longer. They're just asking you out of all these students, which one did the same amount of sit-ups as push-ups? My best advice for this is just start checking, right? If you check every single one of these students, you're going to figure out which student it is. So for example, I could check by saying, well, A is right here. A did 40 and 15. It's not the same. So I could eliminate A. Maybe I want to come over here and check G. G did 40 sit-ups, 50 push-ups, not G. So you keep going. Who's the student who did the same amount? Well, that would be student B. B did 25 sit-ups and 25 push-ups. So we could just say student B. All right, this is my last example. The last thing for you is this practice one. All right, we've got the graph over here. The title is Ages and Heights of Players. On this side, it says the graph below, or again to the right, shows the height and ages of 11 players on the Crystal House football team. Each dot represents a player. Answer the following questions using the graph. The first part of this is which student is 14 years old and has a height of 59 inches. Go ahead and try that. All right. The second question is, how many students on the football team are taller than 60 inches? Go ahead and try that one. Taller than 60 inches. Well, here is 60 inches. And I want taller than that, so that would be anyone above that line I just drew. Student F is 61 inches, also 61 inches, 62 inches, 63 inches, so our answer would be 4. There are 4 students who are taller than 60 inches. The last question is, what do students A and G have in common? Go ahead and try that. Well, student A is right here, student G is right here. Notice that they both have in common, they are 58 inches tall, so that would be our answer. Hopefully you found this video helpful. I also hope you enjoy the Desmos activity that goes along with this lesson today. Please let us know if you have any questions. Thanks for watching.